Inverse of square matrix. Objectives. To understand inverse of a square matrix and its properties. Illustration. In the world of information security, messages are always encrypted. Many systems are designed to work with matrices. There are many ways in encrypting a message. One of them is by using matrices and their inverse. Matrices are used to compress electronic information in the form of a cryptogram, which is essentially a message written based on a secret code. Inverse matrices are also used to solve linear equations. Let us learn more about the inverse of a matrix. A square matrix A is said to be an invertible matrix if there exists a square matrix B such that AB is equal to BA is equal to I. Matrix B is then called the inverse of A. You must note that a rectangular matrix is not invertible. Every square matrix need not to be invertible. An invertible matrix has a unique inverse. If A is an invertible matrix, then its inverse is denoted by A inverse. And A into A inverse is equal to A inverse into A equal to I. A square matrix A is non-singular if and only if A is invertible. Let us now discuss the properties of an inverse matrix. If A and B are invertible matrices of the same order, then inverse of A, the whole inverse is equal to A. Transpose of A, the whole inverse is equal to A inverse, the whole transpose. AB, the whole inverse is equal to B inverse into A inverse. A power k, the whole inverse is equal to A inverse, the whole power k, where k belongs to n. In particular, A square, the whole inverse is equal to A inverse, the whole square. Adjoint of A inverse is equal to adjoint A, the whole inverse. Determinant of A inverse is equal to 1 by determinant A is equal to determinant A, the whole inverse. A is equal to diagonal of A1, A2 and so on up to AN. That implies A inverse is equal to diagonal of A1 inverse, A2 inverse and so on up to AN inverse. A is symmetric implies A inverse is also symmetric. A is a diagonal matrix implies A inverse is also diagonal matrix. A is a scalar matrix implies A inverse is also a scalar matrix. A is triangular and determinant of A is not equal to 0 implies A inverse is also triangular. Every invertible matrix possesses a unique inverse. Illustration. Find the inverse of the matrix 1, 0, 2, 2, 1, 0, 3, 2, 1. Solution. Let A is equal to the given matrix. Determinant of A is equal to 1 into 1 minus 0 into 2 minus 0 plus 2 into 4 minus 3 is equal to 1 minus 0 plus 2 is equal to 3, which is not equal to 0. Hence, A is invertible. By calculating the cofactor of each element of A, we get the cofactor matrix of A as 1 minus 2, 1, 4 minus 5 minus 2, minus 2, 4, 1. Now adjoint of A is equal to transpose of the cofactor matrix of A, which is equal to matrix 1, 4, minus 2, minus 2, minus 5, 4, 1, minus 2, 1. Therefore, A inverse is equal to adjoint of A by det A is equal to 1 upon 3 multiplied by matrix 1, 4, minus 2, minus 2, minus 5, 4, 1, minus 2, 1. Summary.